Hey guys, my name is Marcus D'Ambrosio. I'm one of the co-founders of Adaract, where we've built a high-performance artificial muscle actuator to provide stronger, lighter, and smaller motion solutions. Just to clarify, an actuator is just a device that makes something move. Ours behaves just like your human muscles. So actuators service a pretty diverse set of very high-value markets like aerospace, robotics, heavy equipment, bionics. Just about anything in these industries that you see move is moved by an actuator. So there's already a solution for motion, right? That's nothing new, but it can always be better. People are always striving to make things stronger, lighter, smaller, more efficient, or less expensive, and Adaract can address all of those pain points with our breakthrough artificial muscle actuators that we provide in a single fiber version looking like that weighs less than a penny, or a bundled version that can be any size, any configuration, fulfill any set of requirements. And the most astounding thing about our actuators is they're pretty impressive 20,000 to 1 force to weight ratio. What that means is for every 1 pound that it might weigh, it can actually lift or move about 20,000 pounds. So it's 5 to 20 times stronger than any other industry-leading comparable. So in short, we can make things stronger, lighter, and smaller, as well as provide value with leak-free operation, very lifelike movement, improved efficiency, and we can manufacture them at a very competitive cost. So, why is this valuable? Well, I'm going to use aerospace as an example because I have a good story here that you guys, some of you at least, have probably already heard. But in 1987, American Airlines decided that they were going to remove one olive from all of their in-flight salads for weight reduction purposes. And this ended up saving them the equivalent of $100,000 a year, right? That's just a handful of olives. A more recent study shows that you're looking at annual savings of up to $80,000 or $83,000 per pound removed from an airline fleet. So if Adaract can propose maybe 100 or hundreds of pounds of weight reduction, that's a pretty compelling opportunity. But beyond value, why is this important? So the advanced capabilities of our actuators really remove constraints of the past and can enable the future that we always dream about or see in movies, right? This is truly our vision. This is why our team gets out of bed every single day to build world-changing and life-changing technologies that empower humanity. So our technology is actually based on a fundamental piece of tech called McKibben muscles that have been around actually since the 60s. They've been a big focus of R&D for many years now, still are today, but no one's really cracked the code. So no one's ever gotten them to operate at above 1,000 psi pressure or last for more than about 50,000 contractions. So pretty much they're too weak or they blow up too quickly, whatever. They don't really work. We've blown through these performance metrics with a 3,000 psi operational pressure version that lasts for up to 200,000 contractions, so it's actually commercially viable. This is many, many years and lots of trial and error to get to this point, but we've kind of cracked the code at this point. Beyond just being ahead, we do have some hard defensibility as well. So we have one granted patent right now. We're filing another utility very soon, and we have 2 provisional patents in the filing process as we speak. So Adaract kind of began with a very mission-driven proof of concept in powered prosthetics, which I'll actually talk about a little more in just a second, but right now we're focused on this phase 2, kind of transitioning into an expansion and exploration into high-value markets like aerospace, robotics, defense, and then in the long term, our goal is to be, at least in part, an R&D studio building those world-changing technologies, like I mentioned, both internally and with partners. But let's take it back to kind of... Well, it's not supposed to look like that, but it'll make sense in a second. So back to the beginning. We actually built an entire powered prosthetic leg with our technology to kind of prove the viability, get some traction in the industry, and it ended up landing us our first paid development contract with one of the largest prosthetic manufacturers in the world. So this is super exciting. We're delivering on it right now, generating our first revenue right now. But what's even more exciting is what's to come in the future, transitioning this into a full-scale custom solution development for their product, a new launch of their product, as well as negotiating some sort of licensing and long-term supply agreement and expanding into their additional product sectors. And we believe some of this will be happening as soon as this year. But beyond just prosthetics, our overall focus is to build custom solutions for OEMs in bionics, heavy equipment, defense, robotics, and aerospace. Most specifically, in the short term, we're focused on robotics. We have a very promising lead here. We're actually awaiting a project proposal from them right now, and all things are pointing toward this being our second major paid contract. We additionally have assembled a task force of some private specialists, as well as some really great folks from the Department of Commerce, who've kind of committed to helping us source, secure, and execute on government contracts, as well as put us in connection with the right stakeholders in aerospace and defense to do so. Our beachhead market in prosthetics is obviously not enormous, but can kind of give us some sort of recurring revenue in the short term and a small source in the long term, but our broader commercial potential is absolutely in these larger markets of aerospace, of robotics, and everything else I've been talking about. So our go-to-market strategy begins with demand generation, and in the form of a demonstrated prototype or some sort of early stage pilot testing, and then transitioning that demand into a lead, that lead into a kind of closed contract with custom development for short-term revenue. And we've already proven this works for at least some use cases with our prosthetic contract right now, and then bringing this development contract into a long-term value-generating contract with licensing or supply over the course of years. This is also kind of our bifocal business model, so short-term sustainability-based revenue with custom development, transitioning that into long-term value generation for us with recurring contracts. Based on this business model, we're projecting to reach profitability as early as 2024 and scale to at least $60 million in revenue by 2027, all while holding about 75% gross margins and 52% EBITDA margins. So it is actually a very high margin piece of technology. Based on these revenue assumptions and some pretty conservative revenue multiples from the industry, this type of revenue projection would actually lead this investment to be a 30 to 40x ROI in the future. And if we're looking at a more liberal, less conservative EBITDA multiple, it's closer to 100 times ROI on this investment today. Another big issue with hardware generally is production or manufacturing as you scale. But fortunately, we have a very high value, low quantity type of product. So to reach that $60 million in revenue in 2027, we only need to sell about 26,000 of these, which is not too daunting, right? We've carefully and diligently estimated that to do so, this only takes about 12,000 square feet of facility, only 13 major pieces of equipment, one of which we already have, and about 60 manufacturing personnel, which we believe is very, very attainable as we scale over the coming years. So now let me tell you about the team that's going to make it happen. Some handsome guys up there. First off, we have Joe Hill. He graduated valedictorian from UNR and spent some time in a very relevant role in large-scale production manufacturing at Hamilton Company. Myself, I graduated valedictorian from the University of Utah's College of Engineering, and most previously spent time as a founding engineer and CTO of a small-scale agtech startup that has since exited, and I recently received the 2023 EDOM Founder of the Year Award. We also have Francis Bouda-Manuel, who's an experienced quality engineer, and Clay Payson, who's here with me today, actually, who's an experienced machinist and CNC programmer. But beyond just our founding team, we have a great board of advisors, many of which are investors, spanning all kinds of disciplines. They've been tremendously helpful to us thus far, and will be, for years going forward. They've really been coaching us every step of the way and filling our knowledge and experience gaps. So we're raising at least $600,000 in a pre-seed round right now, almost half of which is filled by our lead investor, Park City Angels. And we're raising this on a safe with a $5 million pre-money cap. With this investment, the primary milestones are going to be sales and marketing based, as well as progressing our current contract with a prosthetic manufacturer to that next stage. Also securing at least one non-dilutive funding opportunity, like a government grant or contract, and filing 3 additional patents. All of this together puts us in a very strong position to raise a larger seed round, which we've confirmed with some institutional investors we've been speaking with. So, in short, we have a disruptive and defensible core technology with a very large market opportunity. We have some early validation in the form of a large paying customer. It can be very scalable, despite it being hardware, and we have a high-performance team ready to execute. So thank you guys for having me here. I'm happy to show you some of our product, actually, after, if you come find me. I have a backpack full of stuff, so thank you all.
Nice to meet you. So, Marcus, really cool presentation. Can't wait to see what's in the backpack, but tell us more about what really excited you to start the company.
So it began, and I should say, one of my partners, Joe Hill, started working on this with us, really, in the form of a passion project, but it was actually based on his uncle, who had ALS, and had a lot of muscular deterioration, lost complete mobility. So Joe was in school for mechanical engineering at UNR, and decided that he wanted to make exercise, right, to help people who had lost physical mobility, and started working on it, built some pretty interesting technology in his dorm room, practically, and we were all friends prior to that, so we ended up kind of coming together and going from exoskeletons into prosthetics, and then realized the muscles that we built essentially were maybe the real sweet spot and then it became a company that is Adaract. But it was really based on helping the people move, which is still our long-term mission at the moment. So.
Amazing.
That is amazing. So, what is the future of Adaract? Does this continue to get smaller and smaller and lighter and lighter?
Yeah, I mean, that's the goal. Honestly, I think we might have a little bit of room to make things smaller and lighter. But let me show you actually, because you'll see that we've done pretty well so far. But this is a little bundle I actually have in my pocket. But I have a single one in here somewhere. Yeah, so yeah, and this one, this is quite longer, but that's like a single fiber version. Single fiber is shorter than that, but weighs like about as much as a penny compass. And that can lift 70 pounds or so.
Just lift 70 pounds.
Yeah, exactly. And the larger one is closer to 7 pounds or something like that.
And this is all built on technology during your presentation since did I hear it?
So the 60s, yeah, it was invented, the core technology that like makes this fundamentally work was invented in the 60s. So it's like a rubber bladder inside of a braided sleeve. That when the bladder is pressurized, it expands, and then the sleeve contracts lengthwise. So it gives you contraction, like a human muscle works exactly the same.
Wow.
And we just made what we consider 100 times better version, right?
That is amazing. Can you tell us a little bit more about your entrepreneurial journey? So you talked about how you started with friends.
Oh yeah. So yeah, for Adaract, this is a good story actually. So my other three partners, Joe, Clay, and Francis, grew up in Elko together. You know, normally Elko, a small town, right? So they've known each other forever. And then I met Clay, who's here with me, my freshman year of college at the University of Utah. We were random roommates there, just like showed up, and you know, he was the other guy in the room, and I was the same for him. We became very, very close best friends. Fast forward a couple of years, we are all in Reno, all four of us, and I had met Joe and Francis along the way, but all four of us ended up in Reno for different reasons, and then came together to kind of bring this technology from a cool invention to a company, a legitimate company, and commercialize it, and you know, really use it for the better of humanity, hopefully, as we talk about, right? But yeah, that's how it's gone from beginning to now, I guess, more or less.
So outside of prosthetics, where do you see market opportunity? I mean, I can think of lots of things myself, but what's the company see as benefits for the future?
Yeah, so prosthetics is obviously where we started, but anything human mobility related, right? That can be an exoskeleton or an orthotic, anything like that. Also any type of robotics, but especially humanoid robotics that you see, you know, Tesla working on, or Boston Dynamics makes back-flipping robots and everything. That's a very natural implementation for this because it has a very biomimetic motion, right, like human muscles. But we honestly think the most valuable application will probably be in aerospace, just because weight savings is king there. And this is substantially lighter than a lot of the options that are currently used. It's an arduous journey getting things into an airplane, right? But we see that probably being the largest opportunity down the road.
I was going to ask you to follow up. I mean, I've always seen exoskeletons on TV and just, you know, on the internet and so forth. They always seem big and clunky, so you're really looking at this would probably reduce the weight by half.
Exactly.
Yeah, provides you the same flexibility and mobility.
Completely. Yeah, it's more flexible, works with your body better, smaller, lighter, obviously, but also safer because these are compliant. So they aren't rigid and they aren't going to center them off or anything, you know. Because they do act, you know, similarly to a muscle, there's just a safer factor involved. But you could wear these across your body, strung on all parts of your body, to literally just make you stronger in every way. And it wouldn't be much more than putting a jacket on type of thing.
I'm ready.
Yeah, I wish. Yeah, so that's and that's exactly what we're trying to accomplish with you know, strategic partners, because implementing this to a product of that scale is challenging to ourselves vertically, right? You know, there's a lot of different assets that go into it, but you know, we're searching for partners to accomplish those based on our power systems. Essentially, we build the transmission, or sorry, the whole kind of powertrain for the car, but you know, there's other things that other people do better. So that's where partnerships come in.
So does opportunity align with profitability? So where do you see the most opportunity for growth? Is that where this product is making the most money?
So it depends. Kind of like I was saying earlier, I think the most logical progression for us is in, you know, prosthetics, orthotics, exoskeletons, robotics, maybe the more intuitive, you know, use cases. but the most like profitable opportunity will almost definitely be in aerospace and aircraft and defense-related use cases. And that's generally just harder to get into, right? There's a lot more barriers from a regulatory perspective in commercial aircraft, at least. And it takes a little longer. So yes and no, we can still be very profitable in prosthetics and robotics or whatever it is, but you know, with the amount of military spending that goes into the next Lockheed jet, right? There's plenty of room for us to make some money, possibly providing components of that to make it a couple pounds lighter, right?
It's amazing. It's still amazing. Just holding it is amazing. So anything else you want to add or share with anybody watching, or obviously People's Choice Awards, so you got some of those people watching online?
No, I mean, more than anything, I guess if anyone watching today sees this and thinks that they know someone or their company or whatever it might be could use this, and we can work together, like I was just saying, in a partnership to build the future, right? Then please reach out. That would be perfect. That's what we're here at these events to do. Obviously, we're raising money, but we're trying to meet people, trying to make things happen for all of us, right?
It's terrific. Make sure anything else?
Last question for you. Angels are upstairs making a couple $100,000 decision. What do you hope that they took away from your presentation today?
Yeah, that's a good question, because I think it can be convoluted always. The biggest thing is we've made drastic improvements in the technology that no one else has really done anything with or been able to do anything with. And we can also, the next biggest thing, especially from their perspective, is these are really inexpensive to make. And we've already built the technology, we already have the IP. So right now it's really just selling them properly. And that's what we want to portray. Is we've already de-risked it largely from a tech perspective. We have the scalability. We just need a little bit of funding to keep us moving forward and continue securing the next customer, obviously to profitability. So,
Congratulations, you did a phenomenal job today.
thank you guys. Yeah,
Thank you.
Nice to meet you.